Now, dear students, all of you see, we will discuss some numerical problems based on moment of inertia of rod. Now you see here, determine the moment of inertia of a rod, which is in which axis is passing through one of its end. This is clamp here, but this rod is inclined at angle theta with the vertical. You have studied this formula already. ML square by 3. ML square by 3. Now, whether there will be any change? See here, again move like this. What is this question? To determine the moment of inertia of a rod of length L and mass M about an axis passing through its end, and this rod is inclined by an angle theta with the axis of the rod. It is not perpendicular. Now, in this case, again you go through the same procedure. Move a distance x and further distance dx. You take a small mass of the rod, a small length of the rod, dx, in which what is the mass present in length dx? dm. Again same, m by l into dx. Now what is the perpendicular distance? Because we have to take the perpendicular distance. We have to take the perpendicular. Now here perpendicular distance will be this. This mass dm. What is the perpendicular distance from axis? This is x. So this distance is x sine theta. The sine theta remains same because it's inclined at a constant angle. Now, the moment of inertia of this small portion will be di, and it will be mass into square of the perpendicular distance. That is squaring of the x sine theta. X square sine square theta. Now we have to integrate this equation to determine the moment of inertia of the whole rod. Yes, but all of this. So what process we have applied? First, we have taken a very small portion of the rod, which is at distance x from the point of clamp. This rod is clamped with the axis, and it is rotated like this. It is always makes certain angle theta with the vertical. With the vertical, it always making angle theta, and it is rotating over this angle in a concept. Now, moment of inertia of this, what is the limit of integration? 0 to L. What is the value of dm? M by L into dx. Into what is this? X square sine square theta. See here, the value of theta is not changing. So sine theta and m by L is constant. M by L is constant. Integration of di is I, total moment of inertia. Now you see here, I is equals to constant term, take it outside, m by L into sine square theta. Now again integration of x square into dx, x square into dx. Take the limit from 0 to L. I is equals to m by L into sine square theta into what is the integration of this term? Power is 2. Power will be 3 and 3 will comes down. What is the limit? 0 to L. Solving this, you will get this answer, m by L sine square theta, L square minus zeros, L cube minus 0 cube, that is L cube upon 3. If you solve this, L cancel out, L square remaining. Your answer will be m L square sine square theta upon 3. Now, in the second problem, if you are asked to determine the moment of inertia of this given figure, if this is a H-shaped body made up of 3 rods, mass length, mass M, length L. Mass M, length L. Mass M, length L. And third rod is like this, H-shaped figure. What is the mass M and its length is L? If I am asking you to determine the moment of inertia passing through the given axis which is perpendicular bisector of second rod, first, second, third. Axis of rotation is passing from here. Axis of rotation. Axis of rotation. You have to determine the moment of inertia of this H-shaped rod. You have to determine the moment of inertia of this H-shaped rod. The mass of all the portions are equal. The mass of all the portions are equal and their length are equal. What is the question here? This is a H-shaped figure made by 3 rods. The length of each rod are L. The mass of each rod are M. Now, what is the question here? This is the axis of rotation passing through the second rod. This is axis of rotation. Determine the moment of inertia. Determine moment of inertia. Now, see here, for first rod, each and every portion lying at how much distance from the axis of rotation? L by 2. For mass third, if you cut all the portions of the rod, this portion, each and every portion lying at a distance of L by 2 from axis of rotation. So moment of inertia is a scalar quantity. So total moment of inertia will be moment of inertia due to first rod plus moment of inertia of second rod plus moment of inertia due to third rod. Now see here, since each and every portion of the rod lying at a distance L by 2, L by 2, L by 2 distance. So moment of inertia of this rod about this axis will be, what is mass? M. And what is the perpendicular distance? L by 2. The square of perpendicular distance. This is very easy. Plus. Due to second rod, see here, axis is passing through perpendicular bisector and see the previous derivation. What is the moment of inertia of this rod about the axis passing through perpendicular bisector? ML square upon 12. Now similarly for third rod, each and every portion, if you cut each and every portion, all this portion is lying at a distance of L by 2 from axis of rotation. So whole mass is M and whole mass is located at a perpendicular distance of L by 2 the square. So your answer will be, what is your answer? M L square by 4. So I is equals to M L square by 4 plus ML square by 12 plus ML square by 4. ML square by 4. What is the LCM? 12, 4, 3 ML square, 1 ML square or ML square plus again 4, 3 times 3 ML square. So your answer will be 33617. 7 ml square by 12. This is the moment of inertia of this H-shaped figure about the given axis. About the given axis. Now all of you see how we can determine the moment of inertia of a circular disk. Of a circular disk. About an axis. About an axis passing through its center. Passing through its center. Through its center. And perpendicular to the plane. इसके प्लेन की परपेंडिकुलर। बेटा ये देखिए 3D में दिखा रहा हूं कि सर्कुलर डिस्क है। बेटा चलिए मैं 2D दिखा दे रहा हूं। See here, this is a circular disc and axis is passing like this, perpendicular to this plane. See here beta, all everybody, mass is present everywhere. Everywhere mass is present. Everywhere mass is present. Plate. This is the disc, means circular plate. What is the mass? M is the mass of the disc. Mass of disc. And this is circular, so R is the radius of the disc. R is what? The radius of the disc. Radius of disc. Now you see here, how we will determine the moment of inertia of this rod about this axis, which is passing perpendicular to its plane. This is 3D diagram. Axis is coming perpendicularly outward. This is x-axis. This is lying in yz plane, and this xy plane. Plane lies in xy plane, and axis z-axis along z-axis means perpendicular to the plane. XY plane. The plane of the disc lies in xy plane, and axis is coming. This is axis of rotation is along z-axis. That is perpendicular to the plane. Axis of rotation. Now how will determine, you know, if we have already determined the moment of inertia due to ring. But see here, if you cut a small ring from 0 to R radius, then we will cover each and every portion of the disc. If we know already that what is the, we have already derived the formula moment of inertia due to a circular ring. What is that formula? mr square. But here the mass m is for whole disc. Now how will determine this one? So for this one, what you have to do? For this, what you have to do? See here. This is the axis. For this, first you have to move to distance x from the center and cut a small circle. Cut a small circle whose thickness is dx. Whose thickness is dx. Set at this region. Set at this portion. This is a ring. This is what? A small ring. We have cut a very small portion of the ring. Let we cut a small portion of the ring. A small portion of the disc in the form of ring. In the form of ring. Form of a ring. Whose radius is x, whose radius is x, and mass is m, and mass is m. No, dm, because m is the total mass of the disc. So its small portion of this is a ring. So its mass will be dm. How we can determine the mass dm? Total mass is m, that is spread over the surface area, pi r square, circular plate. And what is this portion? Since thickness is very small. See, if you take a piece of paper, round piece of paper, circular. If you cut a small ring and remove from it, and if you cut it from the middle anywhere point, it will be, if you open it, it will spread like a rod. This inner portion is, length of this portion is 2 pi x. It will spread like this here. And the length of this portion is 2 pi x. and the thickness of this portion is what? Dx. So you know this is in the form of a rectangle. So area of rectangle is length into breadth, 2 pi x into dx. 2 pi x into dx. 2 pi mass per unit area into area of this will be 2 pi x into dx. Pi cancel out. Now the mass of this portion that is present over the ring is m by r square into 2x into dx. Now we can determine the moment of inertia. Now you see here. Moment of inertia of this ring. Since this is very small portion of the one of the portion of the ring is, so its moment of inertia will be di. What is mass? We know the moment of inertia of ring m r square. What is the radius of this ring? X. What is the mass? dm. dm x square. Put the value of dm. M by r square 2 pi x into dx into x square. You integrate this term by taking, this is the moment of inertia of this portion. Now, this is the moment of inertia of this small circular portion. So, to determine the moment of inertia of this whole disk, we have to integrate, means sum up the moment of inertia for whole such ring, whose radius start from 0 and end to r. Then we can cover the whole, all the rings, and we know that since disk is made up of ring, if you cut this from 0 to r radius, several rings will be formed. So we are determining the moment of inertia of all the rings from 0 to r. Then we can cover the moment of inertia of the disk, and hence we are determining the moment of inertia of the disk. For this, by integrating the above equation, we can determine the what? Moment of inertia of that is. So integration of di is what? I. Constant put outside 2 pi 2 m pi upon r. X square into x, x cube into dx. Integration of x limit will be 0 to r. 0 to r. Here m by r square is there. M by r square is there. M by r square is there. Now, see here, this value of dm is now. Integrate this equation. What you are getting? You see, integration of di is I 2 m pi upon r square. This is x square. This is what? X cube. So integration of x to x4 upon power increases by 1 unit upon 4. So answer will be like this. Mass per unit area upon pi square. Pi also cancel out. See here, dm. How we have determined the dm? Total mass is m, present in how much area of the disk? Pi r square. Pi r square. What is the area of this ring we have obtained? 2 pi x into dx. 2 pi x into dx. 2 pi x into dx. So see here, pi cancel out. Pi cancel out. That is m by r square. M by r square 2x into dx. Pi cancel out. So here pi will be not there. Just remember, pi will be not there. Pi terms will be not there. Just remember, see here, pi terms will be not there. Now, what is the answer? This is r square. Now, 2m by r square. What is the value of, what is the lower limit? 0 and upper limit r. 0 to r. R4 upon 4. Why 0? R4 minus 0. That is R4. R to the power 4 upon 4. 2 2s are, this is square, r square. So moment of inertia of this portion is mr square by 2. What we are observing, the moment of inertia of this circular disc will be mr square by 2. Whereas for ring, it was mr square. For ring, it was mr square. And for circular disc, the moment of inertia becomes mr square by